let's talk about exact numbers. And exact numbers are really something that we compare to measured numbers, measurements. Of course, a measurement is a quantity that was measured with a measuring device and therefore has some limits to its precision. We're going to use significant figures to sort of indicate the precision of that measurement. An exact number is a quantity that was not measured, but was rather either counted or defined. Because an exact number is not measured, there are no limits on its precision, and therefore it has an infinite number of significant figures. So some examples of exact and measured numbers. When we define that 1 foot has exactly 12 inches in it, we mean exactly 1 foot is exactly 12 inches. So both the 1 foot and the 12 inches in that instance are both infinite significant figure numbers. They're both exact numbers. However, when we measure the length of a piece of paper to be 11.5 inches, it is not exact. If we used a more precise ruler, it might be 11.507 inches. If we used like a laser device to measure its length, it might read 11.5068 inches. So each one of those measurements has a different limit of precision. The 11.5 in the first example would have 3 significant figures. The 11.507 in the second example would have 5 significant figures, and the 11.5068 would have 6 significant figures. So we see you can't even say that inches, for instance, are an exact number or not. It depends on the situation. So here's a simple test that can help you decide if a number is exact or not. Try adding an additional 1 at the end of the number and ask yourself, is it possible that the new number might be the true value of that number? For instance, 1 milliliter of alcohol has a mass of 0.8 grams. We could ask ourselves, what about 1 milliliter of alcohol has a mass of 0.81 grams? That might be possible. So that would be an example of a measured number. We have another example, and a sample has 25.4 milliliters. What if that sample really had 25.41 milliliters? That could be possible if it was measured with a better device. Maybe that's what it is. So that would be a measured number. Another example is a sample has 26 atoms in it. Could it be possible that a sample has 26.1 atoms in it? No, because you can't have 1/10 of an atom. You can only have whole atoms. Therefore, we'd say that that is not possible. That is an exact number. But you can't say that atoms, for instance, are always exact. Look at this example. What if a sample has 26 billion atoms in it, or 2.6 times 10 to the 10 atoms? Could it have 26 million, billion, 100 million atoms in it? In other words, 2.61 times 10 to the 10 atoms? Yes, atoms are hard to count. And depending on the precision of the measurement and how those atoms were counted, that is possible. So in this case, that would be considered a measurement. Another example is that 1 meter has 100 centimeters in it. Is it possible that that meter has 100.1 centimeters in it? No. We define a meter being exactly 100 centimeters. So this is another example of an exact number. And just to be clear, the ones in all these cases, the 1 milliliter of alcohol, sample A indicates the number 1 as well, those all would be considered exact numbers. So the ones would be exact in those instances. Because exact numbers have infinite significant figures, we can ignore them when we're trying to determine where to round the place value or the quantity of significant figures when we're rounding a calculation. For example, in this calculation, we have 35.4 milliliters times 0.789 grams per milliliter times 1 kilogram per 1,000 grams times 2.20 pounds per kilogram. When we decide on rounding, notice that the ones in red are all exact numbers. 1 kilogram is exactly 1,000 grams. The 1 milliliter in the per milliliter of that's a density, 0.789 grams per milliliter, and that 1 kilogram, those are my exact numbers. So we can ignore the significant figures in those, and we only need to look at the significant figures in the other values. In this case, they're all 3 significant figures, so we'd need to round the final answer to 3 significant figures. One more thing, I'll just tell you some fun facts about exact measurements. When the metric system and British system when the metric system was sort of defined and some of the situations to convey between imperial units and metric units, we actually redefined the British units in terms of metric quantities. So NIST, the National Institute of Standards and Technologies, actually, when they're measuring something in inches, they've defined 1 inch as being exactly 2.54 centimeters, 1 gallon is exactly 3.785, 412 liters, et cetera, so that we have all of our base standards so some of the conversions between imperial and metric are exact.